Welcome everyone to the CNPS technical sessions. And my name is Franklin Hu. I'll be your moderator today. And today we have Ian Cowan, and he's going to be giving us a presentation. So Ian, why don't you go ahead and introduce your presentation, and then we'll get things started here. It'll be a little bit tricky here, but I'm going to let you go now.
Well, thank you very much, Franklin. And we've just rehearsed actually the mechanics of doing it, and I think it's worked very satisfactorily. So thanks for that. So basically, I was looking at this presentation, which actually is recorded. It was given 11 years ago to the then NPA. And I think a number of you were there. I think Franklin himself may have been present. I'm not sure. I think Harry was, and I think maybe Nick, but nobody else. And I've discussed this with one or two of you, and I think you might be interested in hearing it. So it's only an audio file, but I do have the original slides, and I'll flick through the slides at the appropriate time. So what I need to do now is mute myself, because otherwise there will be an echo. And I'll do that, Franklin, and start the thing. It lasts a little over an hour. So I'll maybe get on, and if there are any specific questions about me, I'll be happy to deal with them along with the questions at the end. The title of today's talk, Electrodynamic Experiments and Theory, a Kinetic Synthesis. Now, that is rather a mouthful. So maybe I'll just say a word as to how I came to this title when Greg had approached me. Well, of course, we're talking about electrodynamics, because that's my paper, both my paper published in GED and the one given in the St. Petersburg conference was simply, simply update on the electrodynamics of moving bodies, just Einstein's 1905 with a couple of words appended to it. So we're talking about electrodynamics. Now, I didn't say electrodynamic theory and experiments. I said experiments and theory. And that was on purpose, because I believe experiments must precede theory. Now, once initial experiments have been performed, one formulates some theories, and then there's a sort of like a process of one feeding back to the other and, refining the system. But I think if one just starts from, on the fireside, theorizing, just out of the open air, spinning theories, and then looks out to perform experiments to see whether your theories are right, it's very, very unlikely that you're going to be, going to the right era. I think actually Sherlock Holmes says in I think it was a study in Scarlet, he said, you must not theorize when you don't have the data, when you don't have the evidence. Otherwise, it tends to bias the mind. So that's why I say experiments and theory and a kinetic synthesis. Well, I want to synthesize the two, because heretofore maybe...
I think a lot of scientists today really need to read Sherlock Holmes, don't they?
Yeah, exactly. Exactly. So elementary. Elementary, my dear Watson. So we need to synthesize, because, the theoreticians are working, and then they're maybe twisting the experiments a bit to sort the theory, and the experimenters are working, and then maybe they're twisting the theory a bit to fit. So we need to have these things working in parallel. And kinetic, well, we're talking about motion and the forces which are involved in that. And maybe also there's a bit of a play on the word that you're motivated to provide a synthesis. So that explains why I have such a mouthful. I do that. Now, this is my only slide which has more than about 6 lines in it. But I thought I would do it. Actually, I do have one more thing to say before I go on to that, just to, the theory and experiment. Out of my later years by Albert Einstein here, and I just thought to mention here where he is talking about mechanics and the attempts to base all physics upon it. Now, so what he says, basically consequent on claiming that the atomicity of matter is sort of something that one can obtain by pure thought. I think that's what Einstein is saying in the preceding paragraphs. But anyway, he comes to the conclusion, we now realize with special clarity how much in error are those theorists who believe that theory comes inductively from experience. Even the great Newton could not free himself from this error. Hypotheses non fingo. I make no hypotheses. Now, okay, it doesn't matter maybe that seems to be at variance with what I've been saying, but it perhaps is also at variance with what the philosopher Immanuel Kant in the Critique of Pure Reason, how he starts the critique. And maybe I'll just take a moment to read it. He says, that all our knowledge begins with experience, there can be no doubt. For how is it possible that the faculty of cognition should be awakened into exercise other than by means of objects which affect our senses, and partly of themselves produce representations, partly rouse our powers of understanding and telepathy, to compare, to connect, or to separate these, and so to convert the raw material of our sensuous impressions into a knowledge of objects, which is called experience. In respect of time, therefore, no knowledge of ours is antecedent to experience, but begins with it. Now, I think I've made the point there, which we can debate, and it doesn't matter who's right and who's wrong, but I just raised the point. However, just before leaving this, I will read a second paragraph, because experience starts everything, but that isn't everything. So Kant's second paragraph is, but though all our knowledge begins with experience, it by no means follows that all arises out of experience. For, on the contrary, it is quite possible that our empirical knowledge is a compound of that which we received through impressions, and that which the faculty of cognition supplies with itself, sensuous impressions giving merely the occasion. An addition which we cannot distinguish from the original element given by sense, which a long practice has made us attentive to and skillful in separating it. It is therefore a question which requires close investigation and is not to be answered at first sight, whether there exists a knowledge altogether independent of experience and even of all sensuous impressions. Knowledge of this kind is called a priori, in contradistinction to empirical knowledge, which at its source is called a posteriori, that is, in experience. So just to whet your appetites there and amplify a little on the experiment coming first. So this is the description which appeared, and let me, as I say, it's the only detailed slide. Let me just go through it so I can perhaps indicate where I'm coming from and where I'm hoping to go. So I'm giving consideration to experiments going back a long time, but mainly in the 20th century, that have been concerned in independent ways with electrodynamic measurements. And electromagnetic energy generated on the Earth, I shall attempt to show to be largely carried by its coordinate frame in its orbit around the Sun, though not in its diurnal rotation. This is a bit like Stokes' system of the ether, or maybe an entrained ether, you could consider it that if you like. And this, together with a reanalysis, this is the other element of what I'm doing, of classical electromagnetic theory, retaining the small but non-zero term involving the electric conductivity of free space, obviously the inverse of the resistivity, which is not zero, leads to a satisfactory explanation of observed phenomena and to a necessary reassessment, so I say, of relativistic and cosmological physical theories developed during the last century. More theoretically now, the analysis entails looking afresh at all the data without any preconceived explanation, and then formulating the mathematical basis of a new explanatory theory. And in this, the D'Alembertian, which is the four-dimensional wave function, the quad system, does not vanish, but is dependent on the partial time derivative of the function and the electric conductivity and magnetic permeability of the medium transmission of electric radiation. Now, I'll give precise equations for that presently. This in turn entails a dissipation on wave propagation through space, which, rather than postulated expansion thereof, accounts for observed galactic spectroscopic redshifts. So, I have no hesitation in saying that there is a tired light system, and in fact, if there isn't a tired light system, we have a perpetual motion system in the universe in which energy can be transferred over great distances without any dissipation. I don't think that helps. So this theory, based on experiments, unlike Einsteinian relativity, is compatible, and so I say, with both available experimental data, some perhaps not adequately explained heretofore, and the essentials of classical physics. So that's where one comes. Now, I've already talked about these. These are the two references. You know, my paper, the update on the electrodynamics moving bodies, was in GG 2003, and then a slightly updated version of that, which formed the basis of my paper in St. Petersburg in 2005, and was published in the Proceedings of the 8th International Scientific Conference. Now, so in introducing it, and I know I'm speaking to most people who will be familiar with all this, but of course, starting with the started in 1881, but in particular the 1887 Michelson-Morley attempt to measure the absolute orbital speed of the Earth, various terrestrial experiments comparing return transit times of electromagnetic radiation over different paths can be considered to have pointed to a null result only if the criterion for non-nullity be the establishment of differences determined by the transitory speeds of the Earth's orbit. So indeed, you know, the textbooks say, oh, the MMX gave a null result. It actually didn't give a null result, unless one is looking at, you know, showing up the Earth's orbital speed. And then, of course, in 1903, perhaps the electrical analog of that, the Troughton and Noble experiments entailing measurement of the deflection of a freely suspended charged capacitor due to a generated magnetic force moving the plates to be parallel to the Earth's velocity, also provided a null result, but only on this premise. The maximum deflection observed was only a small fraction of that expected on the premise, and appeared unrelated thereto indeed. So no further investigation action was then undertaken. Now, however, in 1913, the Sagnac used a spinning disk on which light was sent in opposite directions around the circuit to arrive back at an interferometer, and the resulting fringe shift was quite real, apparently indicating the effect of the spin on the speed of light traveling with or against it. Now, so if we just come here, analysis using electromagnetic theory, so based on Clerk Maxwell's equations, together with more recent experimental data of an accuracy not available at the beginning of the last century, leads to a theoretical formulation that explains the phenomena without the use of theories which have been formulated since the initial experiments, but prior to the availability of these data. The results of modern methods are consistent with the variation in return transit times, depending upon the rotational but not orbital speed of the Earth. And of course, this indicates that a satisfactory solution may be found on the basis of considering electromagnetic radiation, as I said, indeed, as any other form of energy or particulate matter to be carried by the Earth in solar orbit. And this will require a whole reassessment of the nature of the medium, perhaps, through which the radiation is transmitted. I'd just like to say a word, and this is my last point on this slide, about the apparent non-symmetry between how we're treating revolution and rotation. This can be understood when it is considered that the carrying of the energy is more precisely an approximation obtained by considering the orbital reference frame to be approximately inertial, whilst taking into account the accelerating nature of a rotational frame at greater angular speed. Now, effects from the latter can easily evidence themselves in many ways in terrestrial experiments. A signal example is the observed precession of the plane of rotation of a Foucault pendulum in the northern hemisphere clockwise, owing to its Coriolis acceleration caused by the Earth's rotation. This Coriolis acceleration being minus twice the vector product of angular velocity and any additional linear velocity occurring in the rotating frame, whether indeed of a pendulum or of a light signal, is the appropriate, I would claim, measure of non-inertiality rather than centrifugal acceleration relative to the center of revolution or rotation, center of the Earth. The latter for the Earth in its orbit is 0.006 meters per second squared, as against typically 3 to 4 times this value for rotation of a point on the Earth's surface at mid-latitudes, which is hardly a significant difference to determine a major departure from inertiality. However, if we wish to compare the two cases, rotation and revolution, we must evaluate the effects relative to axes fixed in the center of the Earth in both cases. And we see that the value applying to revolution is only about 1 over 366.26 sidereal days in a year, of that applying to rotation, thus being negligible in comparison in regard to an individual experiment. In effect, actually, a gravitational or tidal locking between the Sun and Earth can be thought of, which permits, to the ratio above, complete slippage with respect to the Earth's inertial frame in the case of rotation, and zero slippage in the case of revolution. However, more precisely, locking due to the Moon's orbit, which would be 1 over 27.40, the revolution, must be included, being about 2.18 times that due to the Sun on account of the former's relative proximity, notwithstanding its relative smaller mass. So the Moon is more important for the tides. The combined effect, which is obtained by summing the appropriately apportioned angular speeds, is a locking that decreases the perfect rotational slippage by about 2.6% and imparts an orbital one in the opposite sense, amounting to about 10.5% of the Earth's angular speed. That is one with a period of about 38.62 sidereal days. So if necessary, we can go into that in a bit more detail, but just it's approximately totally carried by the Earth in its orbit, but not by its rotation, its diameter rotation. Now, so I'm now looking at the Michelson-Morley interferometric experiment, which is, as we all know, second order in V over C. So we're looking for very small effects. So in the classic MMX setup, the sum of the forward and return times of light traveling with speed C0 or C0. I tend to put that C0 in or C0, which will become apparent. I'm not the only one to do it, but later on, because I'm considering, you know, like a bit like epsilon naught and mu naught, C naught is a property of a system, other than, say, a system with a dielectric constant. It's just free space, but, you know, is it a vacuum? So I don't call it C because perhaps it's not variable. It's C naught. With the motion in comparison with the sum of the to and fro motion, which we might say crosswind, against the supposed ether flow. So that is from a simple geometric consideration of the interferometer with a one-way length of L and whose transitory speed is V. An evaluation is made of the time differences. And I call this delta T plus because you're looking at a to and fro motion. So you get that equation where gamma is the 1 over the square root of 1 minus v squared over c squared. Now, okay, yeah. I want to come back to say something about the development of the Michelson-Morley experiment. But before I do that, I'll come back to the slide in a second. I'll just go into slide 6. Because in contradistinction to this, the Sagnac system is simply dependent on V over C, or it's related to V over C, because we call it a Michelson-Sagnac interferometric system because we're using a Michelson interferometry, I suppose. So in that setup, the comparison is made between the return times of light in opposite motion around a circuit. So that in this case, where L represents the circuit length and V is the rotational speed, an evaluation is made of the time difference. You know, you work it out, L over C naught minus V minus L over C naught plus V, and you get that. It would approximately be 1 because the speed is so slow, and you get that. That's the angular speed. That's the area of the disk. So most of it are probably fairly well aware of that experiment. Now, okay, so yeah, okay. So what I'll do is I'll go back. Okay, I've just got a note in here which I think I've referred to in the slide, so I'll mention it. We note that the above analysis is for zero inclination of the interferometer to the direction of travel. This is in the AMMX system. And in the more general case, and work it out simply, many of you probably have done it, of an azimuthal inclination phi, an additional factor 1, which I call 1 over gamma s, which is the reciprocal of the Lorentz factor with v replaced by v sine phi, appears in the equation. And the second term is the same with the factor 1 over gamma c, where v is replaced by v cos. And this introduces a cos 2 phi signature into the equation, which indicates maximum difference at 0 azimuth, reducing to 0 at 45 degrees and increasing maximum again in the opposite sense at 90 degrees. So now I'll just go back because we're looking a bit more at the follow-on to the experiments. So as I said earlier, in 1881, the Michelson commenced his observations, and these culminated in the classic 1887 experiment with Morley, the American chemist. The result expected on the basis of detecting the Earth's orbital speed was 0.4 of a fringe shift, and observations were taken over actually just 3 contiguous days, something not highlighted at all in the normal physics textbooks. And the experiment was concluded with the results that, and I quote, "The actual displacement was certainly less than the 20th part of this, 0.4 of a fringe, and probably less than the 40th part. But since the displacement is proportional to the square of the velocity, the Earth's velocity of the Earth and the ether is probably less than 1/6 of the Earth's orbital velocity, and certainly less than 1/4. In subsequent years, various researchers carried out more detailed and extensive tests at various parts of the Earth's orbit and sidereal times to establish if any level of cosmic ether drift could be detected. For we note that in addition to the Earth's rotation and revolution, there is a motion due to that of the solar system through the galaxy, which we calculate as of the order of 300 kilometers per second. So Morley and Miller, very famous detailed Miller experiments, conducted repeat experiments between 1902 and 1905, for which a detected speed of 8.7 plus or minus 0.6 kilometers per second was calculated. Miller, between 1921 and 26, performed, of course, his famous experiments on top of Mount Wilson on the assumption of less ether entrainment at higher altitudes, and from calculations obtained a speed of 10.05 plus or minus 0.33 kilometers per second. Michelson and Pease and Pearson thereupon performed repeat experiments and reported in 1929 a value calculated from the results of the order of several times Miller's value. Now, Miller's extensive Mount Wilson experiments were used to determine from analysis of epochal variations, and this paper is interesting, I think many of you probably read it, the cosmic motion of the Earth on the assumption of a reduction of this and the orbital component in the same proportion. So in other words, giving the result of 2.8 kilometers per second directed to the apex having a right ascension of 4 hours 54 minutes and a declination of minus 70 degrees 33 minutes. I think it was towards Durago, swordfish. Now, further and detailed analyses of these experimental results, interpreted as non-null by the, has been undertaken by Tabanelli. I've given a reference that. Now, okay, yes, okay. So Miller's results have recently been reassessed because you see this thing here. Now, one of the physics textbooks that I was using when I was at college at undergraduate level, had a lot about relativity, and then it just had a simple paragraph at the end. It said some recent doubts about this whole system and so on and ether have been finally put to death by Shankland in a review paper in 1955. And I was puzzled by that, actually, because I said, if physicists are so sure that this special relativity is the correct explanation, what are these doubts, and then what is a Shankland paper? So it's only in recent years that I had a look at this. And of course, Shankland tried to explain away these positive results of Miller, because Einstein admitted actually that if the results were correct, it would take the bottom out of special relativity, the whole basis. But Shankland said, the temperature effects, and Miller hadn't insulated his thing, and so on. Miller was a very, very careful experimenter, and then of course I found out that Shankland was one of Miller's students, and he indeed had custody of the original results, most of which seem to have been destroyed, perhaps by him. So it seems rather strange. So Miller's results have been recently reassessed in terms of reliability by DeMeo and Alaeus. And the 1955 critique of these results by Shankland as essentially due to temporary effects has been shown to be, I'd say at the least, unconvincing. Now, we can skip on to 1932, where the Kennedy-Thorndike experiment reported sensing a daily effect due to the Earth's rotation with a Michelson interferometer constructed with arms of unequal length with different paths. They concluded, however, that there is no effect corresponding to absolute time unless the velocity of the solar system in space is no more than about half that of the Earth in its orbit. In 1938, by analyzing experimental results to measure longitudinal and transverse Doppler effects, Ives and Stilwell obtained a variation in light speed with direction that was interpreted as conflicting with SRT. Okay, so now, it was not until 1963, however, that the experimental accuracy necessary to detect speeds of the order of hundreds of meters per second became available. You know, remember we're talking about like 30 kilometers per second is the Earth's orbital speed around the Sun, whereas it's say 350, maybe at mid-latitudes, meters per second is the rotational. So Jasija et al. Used the frequency shift of masers in a Michelson-Morley type determination. A frequency change with 90 degrees rotation of the device was obtained with about 250 kilohertz, which was somewhat less than that attributable to the Earth's orbital speed, but was considered to be due to local effects such as the Earth's magnetic field. The probable errors of measurement were plus or minus 4 kilohertz, and the change with the time of the experiment of the observed frequency shift was estimated to be 1.6 kilohertz, with probable error 1.2 kilohertz, leading to a result less than 1,000th of that expected on the basis of the Earth's orbital speed, or transitory speed of no greater than 950 meters per second. On the assumption of east-west to north-south 90 degrees rotation of the experiment, assume that's what they did. It wasn't explicitly said. These results were of an order of magnitude not inconsistent with an indication of the rotational speed of the Earth. In 1979, Brillet and Hall used the equipment of a servo-stabilized laser in an isolated Fabry-Perot interferometer with an accuracy 4,000 times better than that of Jasija et al., indicating a null value, 1/2 millionth of an expected result at the base of the Earth's orbital speed, or transitory speed, no greater than 21 meters per second. But, and here's the operative point, only after rejecting a spurious signal of 17 hertz at the second harmonica rotation. And in the analysis which was carried out in 1981 by Aston, he showed that in reality this would be correct within 3% to providing the rotational speed of the location, which was in Boulder, Colorado, of 355 meters per second. And there have been some questioning of this by people like Hayden and Whitney and so on, but we perhaps would need further experiments definitively to pronounce on the subject. My analysis here in terms of effects depending upon angular speed, that is the determinant of departure from inertiality of reference frame, would in any case, in conjunction with gravitational locking, show an effect due to the Earth's revolution of only about 1/38.62 squared of that given in an MMX type experiment, and that's why they didn't show up. Okay, so I'm now going to go to the other type, the Sagnac type thing. And his original experiment in 1913 involved the use of a spinning disk in the laboratory, and the uncertainty has been estimated as 1 in 100. And the results showed a fringe shift, a fringe displacement, determined by the speed of the disk, typically 0.07, for a speed of around 2 revolutions per second. This is the general formula where we have a sort of a delta T minus, where comparing the transit times for radiation going in counter directions. So if the circumference be substituted for L in that formula, and as gamma, as I say, is approximately 1, the time difference is proportional to the angular speed omega, and the constant of proportionality being 4a over c naught squared. So A is the enclosed area. It was about 0.09 meters squared in Sagnac's case. Now, scaling the thing up a little, and a lot of this, again, most of you will be familiar with. In 1925, the Michelson and Gale experiment reported the construction of a closed circuit of piping whose perimeter was of the order of 2,000 meters, relying upon the rotation of the Earth to impart the necessary spin to be analogous to the Sagnac apparatus, with an area equal to the circuit area projected onto the equatorial plane. They measured a fringe shift 0.230 plus or minus 0.005 on average, against a theoretical value of 0.236 plus 0.002, based upon the rotational speed of the location, which was in Clearing, Illinois, in the northern hemisphere, and the results correctly showed a retardation of the anti-clockwise beam of light. That is, that traveling in the same sense as the Earth. Interesting enough, in recent time, Agatha Janellis, in an article in TD, has shown that the small discrepancy between 0.230 and 0.236 actually is not experimental error, but can be fully accounted for by superimposing on the gravitational drag model as proposed by Stokes. In other words, that's where the ether, if you like, is perfectly carried by the Earth. The action of tidal locking, which I referred to earlier, apportioning the sun and moon's values, and showing these effects are, again, amount to only about 1 over 38.62 of that due to Earth's rotational speed in the Sagnac formula. Now, that light generated in the laboratory remained in its coordinate frame and did not take up that of the spinning Sagnac disk, was shown by Dufour and Prunier, who in 1942, they actually obtained no experimental deviation from the results we've talked about when the light traveling on disk was, because it was reflected by various mirrors on the disk, intermediate between source and interferometer, beamed at and reflected at successful mirrors fixed stationary in the laboratory. So the results did not change. So it was actually moving in the laboratory frame, in the Earth's frame. Just as if you threw a ball up, it would be moving in the Earth's frame. It wouldn't be left behind. Now, so we come to more modern times, and in 1963 came the ring laser. McCack and Davis performed a Sagnac-type experiment using lasers and verified Sagnac's results to 1 in 10 to the power of 12. The retardation of electromagnetic radiation traveling with the Earth's spin, that is eastwards in the northern hemisphere, as against that traveling against it westwards, was shown by Saburai et al. In 1976 by comparing recorded times of reception of radio signals in remote stations with those of atomic clocks. I think, the quick answer of mainstream would be to say, oh, it takes the same time for rays traveling in either direction on the Earth. The Sagnac effect was again shown by Maranov, who between 1979 and 1986 studied the photoelectric effects caused by two beams of differing wavelength. Silvertooth in 1987, so we're down here, obtained a similar result, but by using a standard wave sensor, interpreting this as a detection of linear or nearly linear rather than rotational motion. Confirmation of the Michelson-Gale experiment to an accuracy better than 1 in 10 to the power of 20 was performed with ring laser tests on a fixed circuit by Builder it's reported in 1995. In this case, clockwise retardation was evinced, which was correct for the southern hemisphere as the tests were carried out in Christchurch, New Zealand. Now, okay, so just before leaving that, I'll just say something about the optical gyroscope, which is the last bit there. So it is thus seen that an optical gyroscope as distinct from a mechanical one, can be constructed from a Sagnac type apparatus and can be employed, as indeed Sagnac himself suggested in 1914, to measure deviations in the speed of a ship carrying it. Its yaw and its pitch and its roll being determinable from rotation of the apparatus relative to about a vertical axis and a horizontal axis, two horizontal axes, one vertical axis, across and along the vessel. And this has, of course, been now done because ring laser optical gyroscopes, rather than mechanical ones, are now fitted to the latest generation of aircraft, including civil aircraft. And the operation of these devices requires some not insignificant mental juggling to explain whilst holding to SRT, to the special theory of relativity, which would appear to predict that they should show no effect and thus work, because light is has a constant speed in whatever reference frame one is in. So Langevin and subsequently some others, for example, Anandan and Vigier, have attempted this with the aid of general relativity. I mean, a very simple thing is to say, oh, the thing is not inertial or something, but, you know, is that a sufficient experiment? Is that a sufficient explanation? I mean, the Earth is approximately inertial for carrying out mechanical experiments. Anandan endeavor to reconcile this with SRT and the non-relative and with non-relativistic derivations. The studies of electromagnetic radiation have been performed in accelerated systems, such as those derived by Anderson and Ryan, and they're not really in contradiction with my results and my analysis here. But what I'm going to show presently is that I'm introducing a dissipation into the medium, which I think fits with the experimental data. But it is not necessary to account for the Sagnac effect, which can be derived, as in the argument leading to the equation I showed you, because it's just derived by looking at the two different paths about the disk in opposite direction. And Kelly has used the Sagnac effect as the basis, together with other available results that he writes about, to indicate the necessity of a new theory of the behavior of light and relative motion, entailing light being carried by the Earth's coordinate frame in its solar orbit, but not by its diurnal rotation. So from our earlier comparison of the respective levels of non-inertiality of these reference frames and the motion of a point on the Earth's surface, when I refer them both, as I said, to axes fixed in the center of the Earth, and including effects such as gravitation rocking, we obtain the postulate approximately amounting to Kelly's the result there. For non-inertiality, the measure of departure from congruence of the motions of light and Earth and the Earth's coordinate frame. Okay, that's a bit of a mouthful, but it's just basically to talk about that from a unit which Galileo himself talked about being on a boat and doing mechanical experiments, and when one was going at constant speed, constant velocity, one would not detect the motion. Well, and is it possible on that by using light signals to detect the motion of the ship? Well, yes, it is, by a Sagnac type thing. How do you explain that in terms of special relativity? Now, I'm just going back quickly to the, I don't know how I'm doing on time. I'm trying to not to have to rush at the end, so I might be speaking a bit too quickly now. But and Greg, just tell me if I'm too quick or too slow. So the astronomical data start with the Romer experiments leading up to the measurement of the speed of light. Romer, of course, performed observations at times of the eclipse of one of the moons of the planet Jupiter, when the Earth is in successive positive and negative syzygy. So that's a nice word. You know, when they're in line relative to the Sun and Jupiter. And those are the classic experiments, 1973, and that enabled a determination also of the one-way speed of light to be made, which is the formula there. The observations enabled determination of what might be termed the true period, T0, of the moon, because it was delayed, dependent upon how, you know, whether it had to traverse the extra distance of the Earth's orbit. So, but measurements which are not promulgated really 3 years later were done the same way, but when the it entailed determination of the varying periods of the eclipse of the moon and when the Earth is in successive positive and negative quadrature around the Sun and Jupiter. So that is the 90-degree angle is obtended between the directions there. They actually also provide the light speed result, but this time the relative velocity of approach and recession of the Earth has to be taken into account on the basis of respective Galilean addition to and subtraction from the speed of the approaching light. Actually, it is seen that this method is essentially, a determination of the difference of forward and return transit times. You could consider this almost as a stretched out Sagnac disk, which is stretched out to infinity, and between the transit times between the light from Jupiter to the Earth, which I'll call delta T minus. And again, if you just put into the formula delta T minus is equal to C naught T naught over C naught minus V minus C naught T naught over C naught plus V, you get this formula, which accurately provides the speed of light. Now, an independent astronomical measurement of C naught was undertaken in 1728 by the astronomer Royal Bradley, using the principle of aberration. This principle, entailing the use of resolved transitory and light velocities, of course, is consistent with the Galilean composition. Indeed, the system is that owing to the transitory speed of the Earth, v, a telescope to observe a star at an altitude, say theta, must be displaced forward in the direction of the Earth's travel, say to an angle alpha. And trigonometric consideration gives this. Now, I'm expressing that in a different form from that which is given in the classical books. It's basically the same, but I'm expressing it in terms of theta minus alpha, and I'll cover that in a second. So this is actually a sufficient analysis of a phenomenon due to the motion of the observing telescope during the time it takes the observed light to travel down the tube, and is said to have occurred to Bradley while noticing the varying angle of the wind incident on a boat, the Flag, in which he was traveling on the Thames, as the boat's velocity, speed or direction changed. However, and this is very important, it is not simply a reciprocal phenomenon, as has been shown, for example, in the observation of binary stars, which might be inferred from the relativistic derivation of this. No telescope motion during the light passage through it leads to no aberration effect when the star, rather than the observer, is moving. It may also be noted that starlight, unlike light generated on the Earth, is not carried in the Earth's coordinate frame in its solar orbit. And I'll be coming back to that in a moment, because I'm pointing out that because of the motion of the medium through which the light is being transmitted, that gives rise to certain aberration effects, which actually cancel out its motion and lend an effect of memory to the original generating light. I'll come back to that if you just remember this for a moment. So aberration due to the Earth's orbital motion amounting to a maximum displacement over a year of 20.5 minutes of arc is sometimes referred to as annual aberration, to distinguish it from the very small aberration at mid-latitudes, about 1/100th of the value, that results from the Earth's rotation. Now, this expression of the formula here, in terms of the aberration angle rather than the new apparent attitude, so there's the aberration angle, rather than the new apparent altitude, which is like theta dash, which is modified, also yields an explanation of the hitherto puzzling phenomenon, The observed fact that the aberration angle is unchanged when the light speed is changed, for example, by filling the observation telescope with water, as was performed by Bradley in 1871. Now, so my analysis has indicated the following, that what is actually happening is that the reduction in light speed by the factor of the water's refractive index, which should, one would have thought, have led to an increase in the aberration angle, is exactly compensated in this formula here by by the reduction of the ratio of the signs of refracted and incident rays by the same factor in accordance with Snell's law. Or, put more simply, the added refraction due to the water just provides the necessary additional angular displacement of the rays without a further tilt of the telescope. And so, in a way, I mean, I view maybe one of the big conundrums at the end of the 19th century, the beginning of the 20th century, was that the experiments trying to find an ether wind speed comparable to that of the Earth through the ether seemed to give approximately a null result. And yet the aberration seems to give a full result, as if we're moving right through the ether and we can measure that speed. And if it hadn't been for this complete conundrum, perhaps relativity couldn't have been accepted in 1905. And it was never really explained properly. But this business about the wavefront actually preserving its initial status. In the case of starlight, it's coming from outside the Earth's atmosphere, and because of these compensation of refraction and aberration effects, it retains that, whereas something generated on the Earth doesn't. There have been some papers on this. I particularly draw to your attention maybe van der Togt, T-O-G-T, where he had an article in Galilean Electrodynamics in the last couple of years or so on the preservation of the original wavefront, which is the same as this basically. Now, so I just this business here to draw to your attention that a distinction is to be observed between the one-way measurement of light, such as that above, and later terrestrial experiments of the type originated by Fizeau in France in 1849. These latter measure the two-way speed, which we call CM, a kinematic determination, which is return path length divided by time difference. Basically using the equation, we just get that, where the Earth is moving 1 minus v squared over c squared divided by that. Okay, right. And I'll just point out maybe orders of magnitude here before leading the point. As predicted by this result here, experimental determination of the kinematic speed of light found out by two-way observation. These observations are always less than those of its electromagnetic speed as determined by one-way observations, or indeed as shown by electrodynamic experiments. This has been shown by Monti, the Italian writer who's on your list, obviously of dissident physicists. So Monti has said this, and the second postulate of Einstein's formulation, of course, on the contrary, puts forth an identity between these two speeds. Noting again that it is the rotational speed of the Earth that will show up in kinematic determination, the equation that we have up there predicts that the kinematic speed will be less than the electromagnetic speed by an order of 1 part in 10 to the power of 12. And again, that's just for this is zero azimuth, and you can get a more general term by taking an angle out of that. So modern investigations using radar observation of the planet Venus have been undertaken by Wallace, who took part in one of the earlier St. Petersburg conferences some years before I did. Unfortunately, he's deceased now, and he's an American. And Tulshel Nikova Murray, who has been coordinating, or is one of the organizers of these conferences. She also is a lady astronomer in Pulkovo Observatory in St. Petersburg. So they did work, and they reported it in 1991. Yes, and these have shown that the non-constancy of measured values of transit time can be accounted for by the relative motion between the Earth and Venus at the times of observation, exactly in accordance with the delta T minus formula, as indeed was shown by the quadrature experiments of Romer in the case of the Earth and Jupiter, whether the Earth was approaching Jupiter or moving away from it. Detection by anisotropic electromagnetic means of the Earth's motion of 400 kilometers per second through the background cosmic radiation has also been affected. And astronomical observations, and this will be the last thing I'll say before I leave it. I'll be talking about cosmology just before the end, but I'll leave this matter. They thus permit the detection of motion relative to coordinate systems of less locality, such as those of the Sun and of the observable universe, and indicate an isotropy in electromagnetic transmission dependent upon relative motion. So, okay. So, I'm going to look at electrical results now, and let's see how we're doing. I spent an hour on this, and I'm halfway through the slides. So, I want to leave plenty of time though for questions and answer discussion. So, the electrical results. Troughton and Noble in 1903 attempts to measure this torque on the suspended capacitor through a non-zero value. It provided a maximum deflection of 3.6 millimeters, very small compared to the value expected on the basis of the Earth's orbital speed of 68 millimeters. In this case, of course, the torque is determined by the Lorentz force, F equals QV cross B, where we have the force on the charge Q of the capacitor, V is the transitory velocity, and B is the magnetic induction. It is seen basically that the effect should be proportional to the second order of the speed, essentially, as delta T plus, which I talked about earlier, in the sort of, Michelson type, Morley type experiment, rather than delta T minus in the Sagnac type, because B, in accordance with the Biot-Savart law, as well as F, varies directly as V. So you have a sort of V squared there. Now, modern repeat of the experiment using high voltages generated by Wimshurst's machine were carried out by Cornell in 1998. And this is just a thing, a shot from a video he had up on the web. I don't think it's up on the web now, but he had a video which showed this plate deflecting. He argued that the effects only become noticeable when voltages in excess of about 40 kilovolts are employed, so that moving charges inside as well as on the surface of the plates can contribute to the effect. Whereas Troughton and Noble use only about 2 kilovolts. The experiments clearly showed an observable torque, and he published that and so on. Now, so those are further references. Okay, so I've now got the theoretical basis, and I'm now going into a bit of theory. So, what I do is I start from the Maxwell equations for the electric and magnetic field intensities E and H in the linear homogeneous isotropic medium of free space, we're assuming, and also in the absence of free charge. So we have the divergence of the electric and magnetic field intensities vanish, and we have the circulation of those are basically related to the partial time derivative of the other value. But in the case of, so in other words, in the case of the magnetic, we have the additional conduction current. So curl H is equal to epsilon E by dt plus a J term, you see? So we have a displacement current and a conduction current. And so what I do is I equate the conduction current to sigma naught times E. That's using the vector form of Ohm's law. So J is proportional to the electric field intensity. Proportionality constant is the conductivity of free space, sigma naught. Okay. And I was actually a few days over last summer. I spent on the island of Orkney, at the very north off the Scottish coast, and on the ferry from Aberdeen to Orkney, I happened to see a young chap, looked like a student, with a T-shirt with these Maxwell's equations written on it. So I couldn't resist going up to him. I thought, "Are you studying physics or Maxwell's equations?" I mean, so he said, "No, his grandmother gave him the T-shirt. He doesn't know what that is." But being in Scotland, I said, "Oh well." I said, "The man who wrote those was a good Scotsman." Anyway, so what we do is we through the normal system we use some vector analysis, and we work out double curls which are related to the nabla squared or the del squared of the function, and also the gradient of the divergence, and we fiddle around. But remember, I'm doing this with sigma naught E in it. I haven't, those are taken out. If you take those out, you just get the simple wave equation with no dissipation. So what I get is, if I do that, or if one does that, oh, that should be, yeah, that should be a big quad. That's quad squared psi, where psi could be either E or H. Is that, you see, normally we'd get quad squared psi is equal to 0, which would mean that nabla squared or del squared psi is equal to 1 over c squared times that. I think that issue is minus 1. You know, it's the normal wave equation. But you see, what we get is that quad squared psi, which is that, is equal to this value, which is dependent on the time derivative, the partial time derivative function, and also you can see that it's not the it's the speed of light and the conductivity and the resistance of it, or the characteristic impedance. So the speed comes out, obviously, C naught is just the shorthand form of 1 over the square root of epsilon naught mu naught, and this characteristic resistance or impedance is 377 ohms, and it's the ratio between these magnetic permeability and the electric permittivity, the square root of that. So we get that. Now, and I may say, this represents, this term here represents the very small dissipation of energy during wave propagation. If there be no luminiferous ether, as in the first postulate of Einstein's formulation of 1905, then sigma naught equals naught, and this term disappears, and we obtain the simple wave equation, no dissipation at all. In such a case, what may be called the dielectric rigidity of the ether, which is the maximum potential gradient that can exist without the creation of a discharge, is actually infinite. And a non-infinite value of dielectric rigidity was indicated through the vacuum decay effect in 1897 by Trowbridge. So he did show breakdown there, but his experiments have yet to be repeated with modern equipment. Now, you know, again, we look at this dissipation, we see what form it takes. But I say, look, we have an analogous situation. We have people say it is not. It leads you astray if you consider the analogy between sound waves in the medium of air, for example, with properties there, and their longitudinal waves. But you see, here you have, admittedly, the electric and magnetic fields are transverse, but the pointing vector, the energy, the cross product of the two, is a longitudinal energy vector, which is taking place in an area where there are properties. We have the permittivity of the space, we have the permeability of the space, the magnetic, we have the speed of light, we have its characteristic resistance, we have its conductivity. Now, I'm going to show you how that's been estimated. It's been, again, I'm using a lot of Monty's analysis here, but how we can estimate that conductivity. Now, if that's non-zero, well, we have some sort of medium there, if you like. I mean, you know, how can we dismiss that there's something there? Call it an ether, call it a medium. I mean, if it quacks like a duck, so why deny it? So what is called free space is a sustainer not only of displacement currents of electricity, but also of conduction currents, as I said. And it follows that the conductivity is not zero and the rigidity is not infinite, even though these quantities may be respectively vanishingly small and exceedingly large. So what I do then is I just do a bit of mathematics. I actually get into a four-dimensional form using Minkowski coordinates, x, y, z, x1, x2, x3, and x4 is I, C, naught, T, and so on. And I separate the variables and so on. And then I get a solution to the equations. So it may be obtained for the equation by the method of separation of variables, positing that the product of these functions would give a solution, substituting in an equation and getting all the paper. There's more details through all that. But at the very end, what you get is you get simple harmonic motion for the spatial coordinates, and the solutions would be something like xi equals ki cos mix plus phi I. I is 1, 2, 3, where these are constants depending upon the boundary conditions. However, for the time-varying one, we get something like x4 is equal to k4, and I've gone away from the imaginary coordinate ITT back to t, equals k4, the exponential of minus r naught sigma naught c naught t over 2 times cos pt plus phi 4, where again appear arbitrary constants depending upon the initial conditions, and we have a relationship between the factor here, which determines the coefficient of the cosine time. So basically, what we have here is we have something analogous to the telegraph equation, because we have a dissipation, a first order dissipation in time. And what you get for the solution is you get an exponential term. So we obtain a dissipation factor, d psi, for example, we might say, on field intensity at r equals c naught t from the sources. Is an exponential term which governs the envelope of the decaying periodic wave, and we write that as equal to the exponential of minus r naught sigma naught r over 2. However, the Poynting vector, again, if you get the surface integral of E across H dot ds, and you use the Gauss theory, and this is the volume, the triple integral of the divergence of E across H times dV, and it's basically squared up. So the dissipation, the factor of 2 goes out. The dissipation is basically the exponential of minus r, the distance away from the source, over what I call RD, which is dissipation distance, which is given by that formula, 1 over r naught sigma naught, which is depending on the properties of free space. And now, so if you use Planck's law relating energy, quanta, and frequency, the energy dissipation in the electromagnetic wave gives to a spectroscopic redshift. And okay, I'm going to skip this a little bit now, because just to make a little bit of time. Yeah, okay. Fine. Now, if galactic spectroscopic redshifts can be attributed in this way, as I say, to energy dissipation rather than to an expanding universe, thus making the Big Bang theory an unnecessary hypothesis altogether. Proceeding further, we can obtain from cosmological observations of spectral redshifts and galactic distances, the estimated galactic distance, together with the known value of R naught, which is 376.74 ohms, the result that sigma naught is 2.85 plus 1.15 times 10 to the minus 29 Siemens per meter, and this dissipation distance, which is the distance at which the radiation has dissipated to 1 over E of its value, is about 10 to the 10 light years. And we can also estimate the dielectric rigidity as 4 by 10 to the 20. So, and this is tired light, very, very high, very, very low, but not zero and not infinite. Now, and if we graph out this, now Hubble has probably been unfairly given the credit for having said that the Earth, that the universe is expanding all the time from his 1929 observations on redshifts, and of course there were early observations as well, which he built on. He just said, well, an expanding explanation, but there are also tired light. He did say that himself. But if you just take his equation and you take a Hubble value of say 50, value here. Right, per second per mega. And if you take the equation, which I've just deduced from Maxwell's equations, taking the sigma naught in, and we call that the Maxwell law, that's the Hubble thing, and that's the Maxwell value. So comparison of these two would indicate that, is unbounded, so that the dr by h remaining constant as z goes to infinity. The Maxwell logarithmic law is bounded, so that derivative is, where z is the fractional change in wavelength. It goes to zero. And secondly, in analyzing cosmological data using the Hubble law, there is a necessity, which is absent from analysis using the Maxwell law, to postulate increasing values of luminosity of quasars and galaxies. Okay. We also don't. We can say basically also that that the logarithmic law shows a better fit against the observed data. I'm going through this very quickly, but in addition to presenting no problems with matter such as postulated limited age of the universe, which basically, if you get the reciprocal of the Hubble constant of 70 kilometer time, and also explaining the observed Olbers effect illumination of the black bolt of the sky at 2. So, and there's a dissipation energy, which means that there's no perpetual motion in the universe. It seems consonant with the observations we have made without any to the relativity theories. Now we say that in considering the transmissions established early, the speed of light was not a limiting factor. The current in a circuit, now this is not the rate of the diffusion of electrons, which is an exceedingly slow phenomenon by comparison, and the gravitational interaction of masses travel much faster than electromagnetic energy. So, some recent ones, for example, experiments would be in radio electronics in 1983, wrapped these wire frames with gauges of miles and miles of wire around a building, and he worked out by experiment the delay in the electrical transmission. And he found it was practically instantaneous. And Van Vlaanderen, for example, has looked at various aspects of gravitational. He's shown in particular that there's no measurable aberration with regard to gravitation, such as there is with light. You find, for example, at the time of a total eclipse of the sun, that there's an aberration. We projected forward this 20.3 seconds. So in actual fact, there's a delay of about 38 seconds, I think, from eclipse, which can be measured by the gravitational pull, the optical eclipse. So so gravity, the beginning of in the middle of the 19th century, slightly earlier, showed that because of the stability of planetary orbits, that the speed of gravitational interaction would have to be at least 10 to the power of 8 times the speed of light, because had it been the planets would be unstable and they would spiral out. So by the end of following the theoretical work of focus had moved to electromagnetic transmission of energy, and the postulates of SRT were actually following the earlier work on elasticity of Voigt and Lorentz and Fitzgerald and Poincaré. Extended the classical principle of Newtonian relativity reference frames dynamics to all branches of physics, independent of any relative transitory motion. Passing substitution in the law of light propagation. More importantly, the postulates originate the precise results that have subsequently emerged from experiments using modern equipment, and for which the acceptance of these theories has somewhat blinded the mainstream scientific community to looking at the consequences of. So the Lorentz transformation was extended from electrodynamics to ordinary dynamics was unable to pronounce definitively. The variants of the laws governing the various Faraday and Ampere and Gauss laws and so on under Galilean transformation can be shown by following the partial time derivative. The additional term to be added being the scalar product of diffusion velocity and gradient of the function. So this is this capital D by dt. Now, with regard to VM induction, and again, this starts off Einstein's 1905 paper, but I'll just say a word about this. We should note that the effective reciprocity of electromagnetic induction between magnet and coil, entailing just relative motion, holds, despite experiments that appear to show otherwise. And apparent non-reciprocity has been shown by Kelly in some of his monographs, and he's also got it in his book, Challenging Modern Physics, to be essentially due to secondary induction in connecting conductors, taking current back from the coil, thus counteracting the induced current where there is relative motion between magnet and the conductor, when the magnet rather than the coil is in motion, and leading to the rather surprising induction when there is no relative motion between magnet and coil when both rotate together. So he does a lot of experiments in recent years, in the last 10, 15, 20 years, and he shows that it's actually the relative motion of the conductor and the magnet which matters, despite unipolar conduction generation and so on, which seem perhaps to contradict that. Now, so the generalization of SRT in GRT has also become subject to further and fresh analysis in the light of these developments, and some discussion of this has taken place in some of the journals already. The theoretical solution of the geodesic equations for the gravitational field outside an isolated spherically symmetric static body, which leads to the Schwarzschild or Kerr solution in terms of killing vectors, whether it's static or moving, provides the metric ds squared in terms of the spherical polar coordinates, in terms of the Schwarzschild radius of the sun. And this, of course, gives things like the planetary precession, which is 3 pi rs over the semi-lattice rectum of the orbit, and gravitational bending of light, which is 3 rs over the radius of the sun. But actually, there are other choices leading to other metrics. And in fact, the rotation of the sun's inner core faster than its surface, possibly allied to the additional gravitational effect due to the presence of a uniform distribution of dust about it, may be a sufficient explanation of planetary precession when added to that which Newtonian dynamics predicts anyway. It also perhaps is less than satisfactory for modern values of other planets than Venus. Very, very difficult to measure because these the orbits are almost circular. But it's not convincing that the relativistic formula actually gives good values for those. Moreover, a non-constant value of refractive index of the solar atmosphere coupled with mass energy gravitational attraction can account for the bending of light observed by Eddington during the 1919 solar eclipse, half of which is predicted anyway by Newtonian dynamics. And of course, Einstein's equivalence of inertial and gravitational masses can be taken to imply merely an equal acceleration by a macroscopic gravitational field of microscopic gravitational masses. These are almost Monty's words again. I also say that we could note that predictions in the early part of the last century that ostensibly confirmed values of quantities then extant require reanalysis in the light of perhaps specular planetary precession. And indeed, the scale factor used in comparison with the control photographic plates taken in conjunction with the 1919 and analyzed in conjunction with the 1919 eclipse expeditions which took part in West Africa and Prince Island and the other ones in Sobral in Brazil, in South America, but rejected the latter ones, but looked at the former ones. They said the latter ones were not of the right order, two great experimental errors, for example, by temperature effects. This cast doubt on the objectivity of the analysis, notwithstanding the eminence of the researchers and the endorsement of by the then Astronomer Royal, Sir Frank Dyson. Now, yeah, slide 14, it says I should go to now. So, okay. However, I just want to say something about this thing here. If we get this Hamiltonian function of energy here in terms of the change in mass times the speed of light squared and the gravitational potential, and we calculate that at a distance 0 at the origin, say, and at a distance r from a source, and then we divide it. We actually get I don't give the formula. The formula is simple. We get something like z is equal to 1 minus rs over 2 r0 over 1 minus rs over 2 r minus 1, which is in agreement with just a comparing experiment. So in other words, the change in frequency of electromagnetic energy with gravity can be derived by classical methods using the quantum energy formula there. Now, okay. So the expanding universe and the Big Bang theory, 425, were introduced to account for observed phenomena on the basis of what by the time had become accepted theory. And the latter was, of course, Gamow's term for the later 1927 zero-time extrapolation of de Sitter's earlier theoretical expansion model. And, of course, the Big Bang was perhaps a pejorative term given by Hoyle. And, of course, again, we just note in passing that Einstein had first introduced the cosmological constant in his field equations in order to avoid this, but later withdrew it. Okay, now, so now coming to the end. I've rushed a bit through the last part, but I did want to leave at least half an hour for questions. I thought Greg might like that, and I don't want to keep you too long. So, so basically, conclusion. What have we done? Well, I maintain that a satisfactory explanation of the very small effects recorded in attempting to measure absolute motion and of the spectral redshifts observed by distant celestial bodies results from the following considerations. First, the various and independent electrodynamic experimental data now available, which all maybe one could be explained away, very hard to explain all these away. And secondly, the postulation of the approximate carrying of electromagnetic energy generated on the Earth by its coordinate frame in its solar orbit, which again explains the theories. It appears not to explain aberration, but aberration is explained by the balancing out of the refraction and the aberration effects. And this is what really puzzled 19th century physicists. And thirdly, a rigorous investigation. So here, this is where the theory comes in. A rigorous investigation using electromagnetic theory, including the non-zero electric conductivity of free space. This provides further validation of results that have suggested the necessity of revision of basic physical and cosmological theories that have been developed during the 20th century. Thank you very much, everybody, for your attention. I hope it hasn't been too unclear, and if any aspects have been unclear or I've rushed too quickly over specific aspects, or you'd like any more information on any aspects, I can give you the references. But I think there is a bit of time, and Greg might be reasonably pleased that we have a bit of time to discuss.
Excellent. No, you're right on.
So thank you very much.
I'm trying to stop sharing. Have I done that, Franklin?
Oh, yes, you're fine.
Okay.
So thank you very much, Ian, for your presentation there. So although we seem to have some audio problems towards the end, I don't know what that was about. But in any case, thank you very much for your presentation. I guess although I guess my fear is that your presentation was very technical. And so perhaps some of the main conclusions that you were coming up might have gotten a little bit lost in translation. So I was wondering, could you put up your slides again And then I just wanted to ask you a few, top level questions about what the main points you were trying to make was. And also, we have a little over half an hour for questions anyhow. So if you would like to go and join us live and get onto StreamYard and talk to Ian, you can please do that. We also have some people also in the green room. And if you guys have specific questions that you want to ask right away, then please wave or something like that. And we'll try and get you on here. So I see Dennis is waving his hand. So we'll get to you, but so Ian, let's just go to the next slide here. And I just wanted to ask some quick questions about things that may not have been totally clear. So let's go to the next slide. Let's go to your experiments, actually.
Experiments.
So keep on going. So you have your experimental data here first here. So, there was some questions about, are you supporting, say, the concept of an ether here? And, there's some question about whether Michelson-Morley actually produced a null result. So what is your bottom line here with the MX?
Yes, thanks for drawing this out a bit, because I possibly was a bit shy in mentioning ether. I did mention it later on, but the answer, yes, I certainly do. I think there's a medium there, and I'm obviously deriving properties, and I think the only extra property I'm deriving here is the conductivity, which Monty also talks about, and as regards the MMX, yes, it wasn't null at all. Not only was it not absolutely zero, which it would have to be were SRT correct, but the original 1887 experiments, which are quoted in all the textbooks, were only done over 3 days in early July 1887. So we have a lot of experiments, not only their own. They might be 1/40th of what was expected, but we have others, in particular the Miller ones, I think, which many people talk about, which were done the 21 to 26, done on top of Mount Wilson, and perhaps according to my ideas, it's not surprising that they got greater results, because any entrainment of the ether because of these tidal effects would have been reduced at such a high level.
Yeah, I think that's an important point that people always say, MMX was null. But no, if you actually look at the experimental results, there was actually a corresponding, they did find something. It was just much slower than the speed of the Earth orbit. Although, like you mentioned, this is a very crude experiment. I actually graphed the raw data, and it's actually fringe shift all over the place. It's actually a constant curve upwards as far as the fringe shifts go. And, they had to actually subtract that overall slope of the fringe shift to get what they thought was because it's like what's called a constant experimental error is what that is. But it was just extremely crude. And, but your main point here is that the MMX was actually not null, and that there is some data to support that. So let's go to your next slide then.
Yeah, and just before leaving that, and of course it was varying throughout the day. That's true. Although Miller got some correlation with sidereal time, and then I talk about the more recent repetitions, if you like, using masers, say Briot and Hall in 1979, but they appeared to dismiss a spurious, a signal there. I think it was 17 hertz perhaps, and Aspen's analysis seemed to show that was showing up the rotation of the Earth.
Yeah, it's interesting that these experiments can show up the rotation of the Earth, but not its orbital speed. There was a comment about MX being explained by length contraction, right? That's a very common explanation given, but I think that's just simply that was just grabbing at straws. Um, there's no explanation for why it would contract in that direction. It's just sort of an ad hoc. Well, let's just come up with some theory to explain why it was null, but probably it was null because I think one of your main points is that electrodynamics work in the like the frame of the Earth-centered inertial frame, is what you were saying there.
That's basically it. Yeah, that is my contention, which is quite at variance with the simple explanation of maybe there being lengthy contraction to explain why, as they say, there was a null result. Yes, that's quite a fundamental difference there.
All right, let's go to your next slide here, your experimental data 3.
Yeah.
Now, this had to do with aberration. So I was wondering, can you explain to me, well, for example, there's that experiment where they put water in the telescope, and it's like, how on earth would you even expect there be any change just because the water went through the 3 feet of your telescope, which is hardly anything compared to it going billions of miles through space and then through the atmosphere. And so does aberration, I mean, why would that make any sense that putting water in a telescope would change anything?
Yeah, it's a good point. Maybe just for the first one there is I also brought another thing because the textbooks talk about this Romer experiment where he just looked in a straight line when Jupiter was at opposite ends of its or the Earth rather was at opposite ends of its orbit, and you got this extra delay. That's all you see in textbooks. But he also did experiments when it's at right angles, plus 90 and minus 90. And he got the light speed by assuming that you had to take the Earth's approach to Jupiter or recession from Jupiter into account. So that's the first point there. So that's a sort of a Galilean composition of velocities. Now, the aberration is the same. But well, you can look at a limited length of telescope, 3 feet or something long, and you could say, goodness me, you wouldn't notice. But if you're taking a simple explanation of the Earth moving, moving in its orbit, we're talking about orbital speed now. We're talking about revolution around the sun, not the Earth spinning. You would say, goodness me, it wouldn't make any difference. But actually it does. You have to move the telescope forward a very small amount, 20.3 arc seconds, so that when the ray hits the object glass, well, the telescope hasn't moved forward. You're able to hit the observation glass. Now, if you put water in it, well, you change the speed because it's only now 3/4 the speed of light in a vacuum. And you might say that doesn't make any difference. But actually, if you looked at it in a very sort of basic way, you would say, well, yes, you should tilt the telescope forward even more. So I'd have to calculate it, but it might be 30 seconds instead of 20 seconds. But when Airy did the experiment, I think there was a mistake in the speech there, said Bradley, but when Airy did the water-filled telescope, he felt that actually in order to look at the star and have it right in the observation lens, you didn't have to tilt the telescope anymore. And that really puzzled them. But I think I've perhaps solved this because what I did is I was writing these equations. They're normally not written in this form. This is just really the law of sines. You just take the triangles and it's all in the paper I give it. I express it in terms of the difference between the original tilt and the extra aberration.
By the way, is there associated paper that people get asking? I'd like to see your paper.
Sure.
Can I link to it in the chat here? I guess
there is actually a very simple link. There are a number of ones. The best one is on our own CNPS because I actually downloaded it myself just before, so I'd have it on my desktop. Let me see, can I get that for you? a second.
Yeah, let's get that, and we'll put that up.
Yeah. Yeah. What I do is all this is in the paper, although it's not full of pages of mathematics, because I think that's unnecessary, and it's just boring. What I do is I say, look, if you do this, this, and this is the result you get. So if you're really a pure mathematician who wants all the 5 pages in between my lines, you have to apply to me, and I'll be happy to supply it with you. But it gives the basis. Now, let me see how I get that.
Well, the bottom line on aberration. Does aberration support what? What is it saying?
Shall I get you the link first?
Yeah, let's get the link.
Let me see now.
So people have that.
Let's get that, and then we go back to the aberration with your permission.
Right now we're looking at the infinite repeating StreamYard screen here.
Are you viewing what I'm actually doing now?
Yeah, because you're still sharing your screens.
Here it is. Yeah. Okay. Well, then you'll be able to get it.
I want to stop sharing your screens.
No, I'm just trying to get the wiki of the CNPS, which many of you probably have, but I have it here. Well, I had it a moment ago. You can never get it when you're looking for it.
Yeah, you have quite a few things in your bookmarks.
I do actually, and too many. So if I want to find something, I can't.
Well, maybe we'll get to that.
Here, I've got it. Natural philosophy wiki, right?
Natural philosophy.
Okay.
Let's see.
Let me see.
You don't want to do that. Oops. I told him he didn't want to do that because his StreamYard session was on that tab. So, but while we're waiting for Ian to come back here, so let's see. I noticed that some people were waving their hands. Let's see here. So we've got Jim and Vladimir and James. So I know Dennis wanted to say something, but I don't see him. Oh, there you go. Dennis, can I put you up here? Okay, Dennis.
Yeah, thank you. I have three points I want to ask about. First of all, I'd like an explanation of tidal locking. I can understand how a body can, standing alone, if the ether particles are bumping into the atoms of the body, it would be entrained to a certain extent. The atoms, of course, we think of them as close together, but in physics we know that the atoms are mostly empty space. But it seems to me that the entraining of the ether can easily be explained by the ether has particles, excuse me, and the body has particles, atoms, and electrons and protons and whatnot. So you can explain entraining of the ether by this. But how do you explain it by tidal locking? We assume that the distance between the Earth and the Moon is largely a vacuum. How does tidal locking affect the entraining of the ether and the ether velocity in that area?
Oh, okay, Danny. Obviously, I lost the link for a minute or two, Franklin. I thought you might guess that because I've posted the link to the paper in both the private chat and the general chat.
Yeah, that was funny.
I didn't hear everything Danny said, but I heard the last bit.
Well, I just said that if you consider the ether as being particles and of course, matter is particles, then you can see why matter would entrain the ether. There would be as the matter moved through the ether particles would collide with the particles in the atoms of the body, and so the body would entrain the ether. But how does tidal locking be explained then?
Yeah, I may have confused you a little because basically that would be a secondary effect. I mean, the proposition is that the entrainment is caused by the material, by the very large mass of the Earth. If you had a very small, for example, a Sagnac disk, you don't find there's any entrainment. It basically is too small to carry the ether. But so this tidal locking business is a secondary effect, and if you look at the difference in the force between the say what causes the tides, the near side of the Earth and the far side of the Earth, you'll get a difference in force. Well, if you take those sort of effects into account, if you have an ether around the Earth, you'll find that actually there isn't 100% slippage of the Earth through the ether in its rotation, and there isn't 100% carriage of the ether in its revolution. There's about a 2.6% difference. So in other words, it's like 97.4% or something of the ether is effectively carried by the Earth, and there's 2.6%, or maybe it's 2.36%. I've forgotten. Slippage, non-slippage. In other words, carriage of the ether in the Earth by the Earth in its spinning, but that's only owing to tidal effects or gravitational effects. I don't know if that explains it or not.
Well, I was thinking that the collision, if you had a porous body and you threw it through the air, part of the air would move right through the porous body, but the other part would not. How do you explain the tidal locking, the force between the moon and the Earth? Can that still be explained by a friction idea?
No, well, tidal locking is, the moon faces us the same direction all the time, right? That's tidal locking, right? So I actually don't see that there's actually any kind of connection between the ether and that. I just thought tidal locking was due to the fact that the moon has a bulge on one side. It's not a perfectly good sphere. So
that's the converse, Franklin. So in other words, that's the converse. So in other words, we're tidally locking the moon, and that's why the one face is approximately facing us. But I'm talking about how the moon and indeed the sun are tidally locking us, because the forces, the gravitational forces on the near side and the far side are different, and therefore there's some sort of locking. There would be the same. I dare say there would be some locking of the atmosphere. There's you could probably work it out on the molecules of the atmosphere. It's very, very small. It's like a secondary effect.
Now, there were some things in the comments about, what is if there's an ether and if there's an ether bubble, to what extent is the ether locked to the Earth? I know that perhaps Jim, maybe you wanted to say something about that. Let me add you here.
And I apologies. Obviously, I haven't been reading the comments. I normally do when I'm, moderating, but for obvious reasons, I haven't been reading them at all.
But Jim, I think you have some opinions on, and we'll maybe have some questions for Ian about this.
Right. Hi. How's it going?
Hello, Jim.
Can you hear me?
Yes, perfectly.
Okay. Yeah. Actually, according to C.C. Sue's local ether model, the ether is material substance that is proportional intensity to the gravitational potential, and the bubble extends out to where the sun's gravitational potential equals the gravitational potential of the Earth and becomes dominant. So that can be probably around L2, or like 1 million kilometers, but at least past the moon. and we can see that it works with GPS. The pseudo range correction is a Sagnac effect between satellites and cell phone GPS receivers that depends on the Earth's rotation within the ECI, and it shows that an Earth a lab in the Earth on the Earth is moving at about 300 meters per second with respect to the local ether, and that's why Michael experiments have, until lasers were invented, were just too insensitive to detect that. So any results, positive or negative, up until Brillier Hall, should be just ignored.
Yeah, there was some discussion here, comments
And
about
Hayden,
the speed of light is constant. Is it defined as an speed?
I'm sorry. Sorry, go ahead.
It was breaking
Yeah,
up a little.
Yeah, there was discussion about whether the speed of light is actually a constant. And so Ian, what do you think about that? Because it's like on the wiki page, we see that it's defined as a fixed number of meters per second. And that is by definition, right? I believe that's not a measured thing. And it's just defined that way. Although there were some problems with what do you call a second? Because even atomic clocks will disagree depending on their velocity and their altitude, right? So what do you call a second? So what do you think about this whole, is the speed of light constant thing?
And as you say, Franklin, they just defined it as a particular number, which is the basis now of the definition of the meter, rather than this length in Sèvres in France. But
it was measured relative by reflection experiments.
Yeah, but like say it's that value, Jim, plus or minus the experimental error. So they said let's take it to be that 100 with no experimental error.
Right.
And
okay. Yeah, I mean it was measured before they made that decision. In the early 20th century, late 20th century.
But I was perhaps asking Jim. Perhaps you know a little bit more about this for GPS systems that they can't really use it to define speed of light like that. I mean, otherwise they would get your position wrong by a mile.
Yeah, that's what the pseudo range correction is all about. It's essentially
all these corrections to the speed of light for it when it enters through the atmosphere, as it goes through, as the Earth is.
Yeah, there are other factors, but that's definitely one of them. And it's V plus C. It's velocity of.
So in other words, that's the really big one, isn't it? And they have to, because otherwise, you'd end up in a lake. The GPS wouldn't work. So they do take that into account.
Up to 40 meters off because of the Earth's rotation.
Yeah, exactly. So they do take into account. And actually, Kelly wrote to the CCIR or something at the time, and they said, it's we have to take that relativistic factor into account. So he wrote them. He says not relativistic. And finally, they said, well, okay, the terminology might be quite right. So that's right. That has to be taken into account. Even the relative same on the Wikipedia page, right? It shouldn't be C plus or minus V. But but the other things. This we talked about the Sagnac effect, and I didn't mention this in the paper, but actually I'm not even sure if I knew of it at the time. But this Ruyong Wang did these linear Sagnac effect.
2003, right? It got published in Nature.
It got published, yeah, indeed. But you see, so he wrote to me. He wrote to me after one of our talks, maybe some months ago. And I was delighted. I wrote, but the thesis that he was maintaining was that we ought to write to the international meteorological bodies to say that they ought not to take the speed of light as the basis for a unit of length or anything else because it was variable. So I wrote back and I said, of course, I agree with you. But I asked him two things. First of all, I asked him, would he give us a talk on a Saturday? And he bowed out. I'm not sure if his English was not perfect, but he said, I'd prefer not to, but he's happy to keep in touch with us. And I said to him, I was a bit maybe timid. I said, yeah, we could do that, but I actually think it would be useless. We'd write to these people and they'd say they're cranks. They'd either not answer us or we'd get some sort of, feeble answer. But I said we should keep at it. Obviously, I agree with you. The speed is not constant, and it depends on all these factors.
Well, the propagation time is not constant, and the propagation length is not constant.
Yeah,
because it's constant within the ether. It's constant relative to the ECI, but.
Dare I say it? The way the second postulate the second postulate of the 1905 paper, the electrodynamics moving bodies, is written is actually correct. I agree with it. It's not wrong. It says the speed of light is independent of the speed of the source. I agree with that. That is actually quite correct. But the trouble is that if you take, obviously this. We've talked about this before. But if you take it to be totally reciprocal, then that also applies whether the object is moving or not. And later on in the paper, he does that. But that's quite incorrect. That is quite incorrect. Obviously, Jim, you know that. And I think you do, Frank, as well. So we're in agreement about that.
About a lot of stuff. I wanted to point out.
And Sue's stuff is just a very elegant expression, maybe going a bit further from some of these. There's nothing in contradiction. And the only thing Denny, those other effects are really minuscule variations on the general principle that the ether is carried by the Earth in its revolution, but not in its rotation. Subject to those small corrections.
And the gravitational field. So don't talk about friction against the ether, because you'd have friction against the gravitational field in its orbit. But one point I wanted to make that I disagree with you about is aberration.
Yeah.
Beckman, in his book Einstein plus 2, showed that if you consider the halo of ether around the Earth, the ECI, that the alteration of the wavelengths of the waves direction takes place at the boundary where the sun and Earth, essentially the bubble, the outside of the bubble. So that's an easy, simple, intuitive definition or explanation that moots all these questions about Arago and Aries water and all that stuff.
Yeah,
I'm not sure if that's fundamentally different from my ideas. It might be just the expression because.
But if the aberration takes place way out, if the change in angle takes place way out, then nothing is changing at the Earth's surface.
See, I say there's actually a memory. It might be a different way of expressing it. That if the light rays emanate,
it bends it. I mean, Beckman showed in one of his articles in GED how the bending happens. It's just the relative velocity of the Earth.
Did he actually go through the details of, say, the area experiment?
The errors, they were worthless. The aberration has already happened. The angle changes way out.
Yeah, I think that the result was that there was no change, right? I think he was predicting.
Well, the change had already happened. The difference in.
But why should it? Why should it be independent of the speed of light coming into you? I mean, the time it actually takes from, let's say that it happens.
No, if the change in angle takes place because of the mediums moving with respect to each other, if you consider the bubble as one medium and
I did mention van der Togt actually in the thing. He gave a paper in Galilean Electrodynamics some years ago, and it's I think it probably accords with my idea.
Yeah, okay, I'll send you a link.
We're kind of getting towards the end here, and I know that that James
Sorry.
wants to say something, so I'm going to give him a chance to come up.
Thank you for your time.
Thanks very much. Thanks, Jim.
All right. So James, you had some questions?
Yeah. Hi, Ethan. Great job. A very praiseworthy scholarship. Actually, I think your work deserves a whole series of presentations broken up part by part so we can digest it better. Some questions about first, you talk about an isotropy. Is there any anisotropy that you have noted in your work on these questions?
Do you mean like terrestrial anisotropy?
Well, yeah,
Or
any
general
lack of symmetry,
anisotropy?
any lack of
Because
symmetry, you know.
Obviously, I do consider that you can measure the speed of movement of objects like the Earth through the background radiation, for example, or you could measure the speed of the sun or even the galaxy through that. So that in that sense there is an isotropy. But I didn't know if you meant like on the Earth.
Well, I that was just a general. I'm just picking your brain a little bit here. Now, with the what about conservation of energy? You're claiming that light loses some of its energy. Is that correct? And
Yes.
where does this other energy go, or is it what's the story there in your mind, sir?
Well, it is there that I would see some analogy with what Denny raised about friction. So, in other words, let's conceive of electromagnetic energy coming from distant parts of the universe to us, and I conceive of a dissipation, and I've worked it out with formulas and numbers. Now, where that goes, I don't know. Could it be heating up the ether because there's ether everywhere, or could it be engaged in moving the composition of the ether, which is the same thing, I suppose. I'm actually very, very, very hesitant to make any comments about the ether because I really believe we need data. We need more data. So I'm happy that there is an ether and that we can derive its properties, but it's whether it's sort of a molecular, positrons and electrons, which are maybe moved more quickly because of this energy. I don't know, but all I know is that this energy probably gets scattered into the ether in some form or other.
Okay, great. Now, as far as the redshift possibly being in part a slowing of the speed of light, wouldn't that mean that the individual peaks would arrive at greater intervals and therefore appear to be a redshift, perhaps an object moving away, but really it's because the light slowed for a period of time in its transmission through a volume of space?
Well, yes, to the extent that this spectral change could be misinterpreted, if you like, as a recession, but no, in the sense that I don't think it's necessarily a change of speed. I think it's a change of energy, because basically the frequency determines the energy. There's less energy, so therefore the frequency is less, and therefore there's a redshift. It's like an energy transition. But I do agree with you that it has been misinterpreted as a Doppler shift.
Well, thank you. Perhaps others have questions. Thank you, Ian, again.
Thank you for those questions, Jim. Thank you.
Yeah, I think that's an interesting question about the whole redshift thing. Like me personally, I did an experiment where I just threw a rock into a smooth pond, and you can observe that where the rock came in, the frequency is very small, but as the wave travels across the pond, you can see those waves spread out, just naturally. So I think that would be a very good analogy for what might actually be going on with an electromagnetic wave, that it is somehow losing energy to the medium, and the light waves are just expanding out, right? And it's been disparagingly called tired light, and I think some of their arguments are defective in that they're thinking that maybe the light wave gets longer, but still maintains the same width, pulse width. But no, it would get wider, right? A 1 second pulse would become 2 seconds if the frequency was reduced by half. And so I think something which would be indistinguishable from Doppler redshift, really, in any conceivable way, I suppose.
See, as you perhaps are saying, Franklin, the tired light business, it seems to be a bit of a pejorative term. I mean, frequently they say, it's only tired light, it's rubbish, But actually, Hubble postulated that as well. He said in 1929, we know there's a red shift. Now, he said, a very good explanation is that it's tired light and there's energy dissipation. And another explanation, perhaps, is that it's Doppler recession. But that's got twisted around in the narrative that he disproved tired light and he introduced, the Doppler effect. That's quite at variance with the facts.
Okay, so we're getting towards the end here, but I did want to ask you about there was a lot of very complicated mathematical stuff with Maxwell's equations, but I didn't really get, what was your main point with that? Why are you bringing that up?
Yeah, my main point, and I've gone a bit further in later papers, which I think I gave you a talk on the analogy between electromagnetic, and I know we've talked about this and sound, but you see, if you look at Maxwell's original book on electricity and magnetism, he actually does have a conductivity of the ether in there. I call it sigma naught. I've forgotten what he called it. I think he has a C. It might be a German C or something, a Gothic C, or K maybe. C, I think it is.
That's interesting. You say conductivity of space, you see, but if space actually conducted, then it would conduct electromagnetic radiation just like a wire conducts electricity, wouldn't it?
If the conductivity were, you see, actually, it was, I think it was J.J. Thomson himself, the man who actually detected the electron, who quite naively said, the conductivity of the atmosphere must be zero, because otherwise things would break down. I mean, this is a very, very, very small quantity, and you must also make a distinction between conduction and displacement current. Conduction current and displacement current. So I make the distinction between those two things, and I also keep what Maxwell put in. It's been deleted by modern physicists, certainly following Einstein, because Einstein basically says the conductivity is zero. So in other words, if you had no means of establishing that you're moving through an ether, well, then it wouldn't be there. There's no ether and the conductivity is zero. And the way Maxwell's equations are written nowadays are with no conductivity in. But if you go back to Maxwell's original 1873 book, you find it's actually in there. So all I've done is I've retained that. And I've done a bit of fancy mathematics, and I just get that RD, if you remember, that it's exponentially decreasing. And I find RD is the dissipation distance, I call it. So I find that after about 10 to the power of 10 light years, the light coming from a distant nebula would have decreased in energy to 1/e of its value. So that's the only reason I put that value in.
So you're just trying to explain why the light expands. Is that what the point was?
Yeah, I'm trying to give a reason. I mean, the current physics book, what they call Hubble's law, it's not really Hubble's law because they're saying he only had one explanation. They say it's just linear, and it's the universe expanding. And then they find it's actually not linear, because I say it's exponential. So that they say, it's actually accelerating. We used to say it was decelerating from the Big Bang. Now we say there was a, what's the word they say? I've forgotten the word. Accelerating expansion.
Well, in any case, so we have already come to the end of our 2 hours. It always flies by so quickly. So why don't I let you summarize, and then you can close out the session.
Well, thank you very much, and thank you very much for stepping in, Franklin. I did ask you because I know you're a logical man who's capable of conducting these meetings very, very well. So thank you very much. I'm delighted that I was able to show this again. I think I've explained this to Franklin, but we were going to have a talk today. I think it was by John Hodge, and he's taken ill and so on. So I have a couple of offers from Nick for videos, but actually I've persuaded John Hodge to allow us to play his videos, and I think he may be in the background, but I think he's not well enough to conduct these talks. So I took it upon myself. I had a brief discussion with some people, and this talk that I gave in January 2013 to the NPA, I think it was very well received. Actually, it encouraged me to get more involved with society and so on. And it also led me to the introduction to Glenn Baxter's group, the late Glenn Baxter, who they used to meet on Mondays discussing it. So I said, well, it's somewhere there in the archives. We don't have a video of it, but we have the audio, and maybe I'll play it and see what people think. I noticed a number of the questions, over the weeks and months have actually been related to the sort of things that I've been dealing with. And Jim says, we could maybe split it up and go into more detail in regard to some of the parts. So I'd be very happy to do that. Delighted to do that. But have a look at the information, and do keep in touch with me. It's something which I'm delighted to have been able to put in actually as a record on the new CNPS site as well, because otherwise there was a possibility that it would get lost. Whether I'm right or wrong, that's for all of us to discuss at a later stage. So thanks very much for your attention. Do keep in touch, and thank you very much, Franklin, for hosting the meeting for me.